What is a daemon thread and what are its use cases? They are background threads. They doesn't prevent GVM from terminating. They are scheduled only on idle CPU timing and they serve other threads. A daemon thread runs in the background and it doesn't prevent GVM from being shut down. GVM shutdowns daemon thread whether looking the thread running or not after all the user threads can get completed. The daemon threads are low priority threads that provide the background support to the user threads. They provide services to the user threads. And also a child thread created from a daemon thread becomes a daemon thread as well. How to create a daemon thread in Java? We can create daemon thread by setting its setDaemon value as true. GVM shutdown waits only for user threads, not for daemon threads. GVM will wait for user thread to finish their task. GVM will not exit until all the user threads finish their tasks. On the other side, GVM will not wait for daemon threads to finish their tasks. It will exit as soon as all the user threads finish their tasks. User threads are executing in the foreground, whereas daemon threads executing on the background. User threads are foreground threads. They always run in the foreground and perform some specific task assigned to them. Whereas daemon threads are background threads, they always run in the background and act in supporting role to the user threads. A daemon thread running in the background that doesn't prevent GVM from terminating. By default, a thread created in a Java program is a user thread. However, we can make it daemon by calling setDaemon_true method if needed. User threads are high priority, whereas daemon threads have the lowest priority. User threads are the B threads. They are designed mainly to execute some important task in an application, whereas daemon threads are the fewer priority threads. They are designed to serve user threads. By default, a thread is created in a program always is a user thread. However, we can make it daemon by calling setDaemon_true. The daemon threads are low priority threads that provide background support to the user threads. It provides services to the user threads. A child thread created from a daemon thread is also a daemon thread. User threads are generally created by application, whereas daemon threads are mostly created by GVM. User threads are created by application to perform some specific task, whereas daemon threads are mostly created by the GVM to perform some background task like garbage collection. When we create a thread in a program, it's known as a user thread. A child thread created from a daemon thread is also a daemon thread. When we create a thread in a Java program, then it's called as a user thread. We cannot make a user thread to daemon thread if the thread is started. User thread is designed for specific tasks, whereas daemon threads are designed for support other threads. GVM doesn't force user threads for termination, whereas daemon threads can be terminated by force. GVM will not force the user thread to terminate, it will wait for user thread to terminate themselves. On the other hand, GVM will not force daemon thread to terminate if all the user threads have finished their task. When there are no user threads running, GVM shuts down the program and quits. A daemon thread runs in the background and doesn't prevent GVM from being shut down. Once all the user threads get completed, the GVM shutdowns being bothered whether a daemon thread is running or not. A daemon thread is run in the background. As soon as all the user thread finishes execution, Java program or GVM terminates itself. GVM doesn't wait for the daemon thread to finish their execution. As soon as the last non-daemon thread finished, GVM terminates no matter how many daemon threads exist and running on the inside of the GVM. Green threads versus native threads. Because of the limitations of green threads compared to native threads, it has been removed from the earliest Java version. They have been removed in the 1.3 version of Java and it is obsolete now, but it is still good to know features and the differences compared to native threads. Green threads swap the control when the thread blocking method explicitly declared, whereas native threads switch the control from a running thread to a non-running thread at any time. Green thread refers to a model which threads are scheduled by Java Virtual Machine itself. Java Virtual Machine creates, manages, and context switches all the Java threads within one operating system process. Green threads only switch when control is explicitly given up by a thread or by a blocking operation such as thread yield, object wait methods. Native threads can switch from a running thread to the non-running thread at any time between threads preemptively. Green threads usually run on only one CPU, whereas native threads can run on distinct CPUs and consume all the CPU time. Green threads are platform dependent, whereas native threads are platform independent. Green threads does not rely on the OS while emulating multithreading environment. Green threads run code in user space that manages and schedules thread it has written to enable Java work in environments that do not have native thread support. Native threads named because they belong to native platforms. Green thread adapts to library approach, whereas native threads map a single Java thread to an OS thread. Hence, green threads adopts to thread library approach. They are invisible to the OS. On the other hand, native threads refers to an in which the Java virtual machine creates and manages Java threads using the operating system library, and each Java thread is mapped to one library thread.